Okay, a little review of logarithmic functions. Basically, I have the definition of a log function. When you have the equation y equals log base a of x, this is true if and only if x equals a to the y. Basically, what you do is you take the base and put it to the y value. I have a special way to remember that. I remember this trick. Logs always equal exponents. So I would say log base a of x equals y, and then I draw a little arrow from the base to the value, and that value is the exponent. All right. So whatever a log is set equal to, that number is equal to an exponent. Logs are always equal to the exponents. So then you say that the base to the exponent equals the value of the logarithm. So let's do these. Log base 2 of 32, what does it equal? Well, set it equal to x. And then draw the arrow. Base, logs always equal exponents. So base to the exponent equals 32. Now this becomes easy to solve because you can rewrite 32 into the base x. You can write 2 to the x equals 2 to the 5th. I bet you know what happens now. Since this equal sign is true, you must know that x and 5 have to be equivalent to each other. And indeed they are. So, let's do another one here. All right, first of all, set the equation equal to x, and then draw an arrow, base to the exponent, because logs always equal exponents. So 10 to the x equals 1 over 100. Do you mind if I write 100 as 10 squared? And then I'm going to write 10 to the x equals, I'm going to use negative exponents, 10 to the negative 2. How cool is that? And so x equals negative 2. I got a couple more to do. Why don't you try to do these, turn off the video, try to do them, and then turn me on again and see if you get them right. Okay, hopefully you're done. Here we go. Set it equal to x. Draw an arrow, because logs equal exponents, so base to the exponent. 3 to the x equals 27. 3 to the x equals 3 to the third. X equals 3. How about this one? Set it equal to x. 3 to the x equals 0. This one's tricky. You have to know the rule for this one. Hey, there is no rule for that one. You know why? X has to be greater than 0. All right? There's no way 3 to anything can equal 0. So that was a trick question, and you should never get one like that. All right? And try on your calculator log of 0. It doesn't work. Okay. All right, here's another one. Set it equal to x, and then go 4 to the x. 4 to the x equals 2. Make that 2 to the 1. And then make this 2 squared to the x equals 2 to the 1. How about 2 to the 2x? Go up here. 2 to the 2x equals 2 to the 1. So 2x equals 1. X equals 1/2 in this case. So these logarithm problems are pretty easy. They're given to you in logarithm form. You're going to rewrite them into what's called exponent form. Logs equal exponents. So set the log equal to a variable x. And that's the exponent. And then do base to the exponent equals the value. I always call this part the value. I have a picture representation of a log problem. I call it like this. I say log to the base, the log of some value, to some base equals the exponent. There's my word picture representation of this problem. And then it's always base to some exponent always equals the value. And this works for these, right? Base to the exponent. So 2 to the x equals 32. 2 to the 5th equals 32. 2 to the 5th equals 2 to the 5th. So, these are pretty easy. Good luck with the log problems.